All right, we're back. Last time we learned about the Big Bang. Today we are going to learn a little bit about how everything has been structuring itself in the universe since then. And like I said, after a few billion years, galaxies were taking shape, and today we're going to learn about galaxies. So first of all, the basic building block of our universe is the galaxy. Just like you and I are made of cells, the universe is made of galaxies. You can think of it that way. Now, the galaxies are, of course, made of lots of other things smaller, but so are cells. What are galaxies? Well, they're collections of billions of stars held together by a gravitational glue. Often, a black hole is at the center or the core of a galaxy holding it together. You'll also see at the center or the core of galaxies many, many more stars than on the outside outskirts of galaxies. So it looks much brighter there. That's just because there's a lot of suns very close together. But as far as the definition goes, collections of billions of stars, planets, gas, and dust, all held together by that mysterious force we call gravity. You can see on the right-hand picture here, that's the Andromeda Galaxy. And on the left-hand picture, another spiral galaxy. So there are different types, speaking of spiral galaxies. There's an elliptical type galaxy, kind of like an oval shape, and they don't have much structure. They don't rotate very well. There's not a lot of star formation, a lot of old long-lived red stars because of that, but they can be very large, and they're very common too, actually. All right, spirals, by the way, ellipticals right there. Spiral galaxies, like our own Milky Way galaxy, these things are disc-shaped, kind of like if you look on the side view, they look like a flying saucer type shape with a bulge in the middle, and it's kind of fanning out towards the edges. And they have arms, spiraled bars as they move around. And they rotate, and there's lots of interstellar dust and gas promoting lots of good star formation, plenty of young stars. Most of the star formation occurs at the core and along those arms. And these are normal spiraled galaxies and barred spiral galaxies. So ours is a normal type spiral compared to a bar type. And then the third type really doesn't fit into a category very well, and these often will populate around other larger galaxies, kind of like little satellite galaxies, but they don't have a regular shape, and they could be the result of collisions of other galaxies. We're not really sure. They contain a complex mix of everything, young and old stars, and they look like just about anything. So the three types of galaxies, and of course you can get much more detailed than that. There is a photograph of an elliptical galaxy. An irregular doesn't take much of a shape. Now I'm not talking about this one over here. I'm talking about the one in the middle. Spiral galaxy. This one looks like it has some kind of bar to it, doesn't it? The center core is right here. Perhaps a bar spiral. There's another one. You can see the spiral arms, central core, the other spiral arm coming off. And there's our Andromeda Galaxy. It's a kind of a sister twin to our galaxy. It's the closest galaxy to us, and you can actually see this without a telescope or binoculars. If you know where to look, you can kind of see it with no aid at all to your eyes. And these are some of these little satellite galaxies I was talking about before. Those you need a telescope to see. The Sombrero Galaxy. This has got to be one of my favorite photographs of a galaxy because it looks so three-dimensional. And we're looking kind of flat in on edge. You can see there's the spiral arms, and the central core is just so dense that there's a lot of bright light there. And colliding galaxies. Galaxies do actually run into one another, and that could actually create some of these irregulars that we were talking about before. In fact, we're on a collision course with the Andromeda Galaxy, and someday we will collide. Of course, most everything in our galaxies will miss each other because space is very spacious. And this is an artist rendition of our galaxy looking from a top-down view. We don't have any photographs of our galaxy from this far away, obviously. It's just too far away to send something to take pictures back. But the central core, right here, We're not there. We're actually out a little ways. We're here. Like those t-shirts, you are here on the Orion arm. And there's various other arms. The Perseus arm, of course ours, the Orion arm, Sagittarius arm, Cygnus arm. And we're spinning this direction. And there's our galaxy looking in toward the central core. At nighttime, if you kind of look towards Sagittarius, that's kind of towards the core. But you've probably seen the Milky Way, which is just looking through those spiral arms towards the core of our galaxy. You can definitely see that central bulging disk right there where the majority of stars are located really close together. And probably a nice big black hole right in the core. And that is it. Quick lesson today on galaxies.